In this video, we're going to talk about circumference and the arc length. So the arc length, when you look right here in your circle, when you're going to copy this down onto the red circle from class, the arc length is a certain length around the outside. So circumference is the distance all around the circle, but an arc length is only a portion of that. So it's a percentage of the circumference. So this is one of the formulas that we're going to be using. So you just have to think of the percentage of something. We take the percent number, so the part out of the whole, and then we multiply it by their circumference, so 2 pi r. So that's going to be our general setup. So make sure you copy this down onto your circle, and then we can practice the questions. So for on these questions, we want to find the circumference of a circle with a radius of 9. So remember, the circumference equation is 2 pi r that uses the r in there. So all we're going to do is just plug it in. So we have 2 times pi times our radius, which is 9. So I'm going to combine my constants together, so I get 18 pi. So my exact answer, so we're going to start seeing exact versus estimate, is 18 pi centimeters. If I actually multiply those together by using the pi button on my calculator, I get 549 centimeters, and that's the estimated. So on each of these questions, I'm going to write the estimated answer and then our exact answer. So on the next one, if the radius, we want to find the radius if the circumference is 26 meters. So remember, we have 2 pi r, and we just fill in the pieces that we've got. So we have the circumference, that's our 26. The 2 times pi times r, we don't know what the r is, so that's staying in r. So first we can divide everything by 2. So we have 13 equals pi times r. Then we have to divide by the pi symbol, so go ahead and divide that on your calculator. So when you do that, we end up with 13 over pi, and that would be my exact answer, which you're really not going to write it like that so much, and that would be in meters. Or if we actually type it in, we'd get 4.138 meters for my radius, and that would be my estimated answer. That's probably the more common one you're going to see between the two of them. On this question, we're going to go through as a real-life question on how far it will actually, this tire will actually move if we rotate it 15 times. So in 15 revolutions, how far does it actually travel? And notice it's in feet, and our original measurements over here are in inches, so we're going to have to do some conversions at the very, very end. So first, we need to find the circumference, but before we do that, we need the diameter. So the diameter, we need to add our 5.5 to our 15. So the diameter ends up being 26 inches. Then for our circumference, remember the formula is 2 pi r, or we can do the diameter times pi. So since we already have the diameter, we might as well use that. So we'd have 26 pi inches. Now remember, that's the exact, but if we want to find out the nearest foot and the 15 revolutions, we want the exact measurement, or sorry, the estimated as measurement. So we would actually know how far it has reached. So this would be 81.681 inches would be my circumference. So since this is in inches, we don't want to change to feet yet, but let's deal with our revolutions. So because we want to go 15 times around a circle, we need to multiply this by 15, and I get 1,225.221 inches. Now if we want to change it into our feet, we need to divide it by our 12 inches per 1 foot. So when I divide that by 12, I get 102.10176 feet, but it is the nearest foot, so we're going to say 102 feet is how far our tire would go in 15 revolutions. So now we're going to practice finding the actual length of the arc, so that means the distance around the edges of the arc, not the measure of the degree. So just be wary of that, that the length means it's the actual distance, not the measure. So remember, we want to take the arc is equal to the degree over the part over the whole, so our 360 degrees in a circle. Then we need to multiply it by our circumference, since it's part of the circumference. So there's the general equation we're going to be using on each of these. So since the arc is the x part I want to find here, I'm going to go x equals the degree of that, the measure of that degree is my 60 degrees out of my 360 times 2 pi, and then my radius is 8. So one thing I usually do is I multiply all three of these numbers together. So 2 times 8 is 16. 16 times 60 is, let's see, 960. So I have 960 pi over 360. And then I can go ahead and divide that. So first you want to multiply the 960 times pi, then divide it by 360. So I get 8.378. And that is centimeters for the length of that arc. So for the next question, we're going to use the same setup. So I need to find my arc. So that's my x. The degree is my 60 over the total in my circle times my circumference. So 2 times pi times 11. And again, I want to multiply all three of these numbers together. So 2 times 11 is 22. 22 times 60 gives me 1,320. And then I still have the pi with it, divided by 360. So now go ahead, type this in the calculator, then divide by 360, and I get 11.519, and this is centimeters. So remember, it's not degrees, it's the actual length of that arc. All right, so for the last one, I have my angle is the part I'm trying to, or the arc length is what I'm trying to find, so there's my x. My degrees, my part out of the whole. So my percentage times the circumference. So 2 times pi times r, so my 11. Again, I want to multiply my 120 times 2 times 11. So this is 22 again, times 120 gives me 2,640 pi divided by 360. So again, multiply that, then divide by 360, and we get 23.038, and this is centimeters again. So here we're going to use the arc length formula to find some different pieces. So in this one, we want to find the circumference of C if they give us the actual arc length. So remember, our formula was the arc length itself equals the degree, so the part out of the whole, so my 40 over 360, and then times my circumference, is 2 times pi, and then we do not have the r. So we need to find the r value, so we're going to keep it as the r. So now we can simplify a couple things. I'm going to combine my 40 times my 2, so this is really 80 pi over 360 times my r. On the other side of my equation, I still have my 4.19. So here's one thing that you're going to want to notice is I want to get rid of the fraction just because that's going to be easier. So if I multiply this side by 360, it's going to cancel that fraction out. So we need to multiply by 360 on the other side as well. So that means the left-hand side gives us 1508.4 exactly, so don't round it, just leave it the way it is. And then I have 80 pi times my r. So I need to divide by 80 pi, and notice I'm keeping parentheses in it, and you need to do the same because when you type this in your calculator, you need to keep parentheses around it. So when I do that, I get 6.002 inches, and remember this is our radius, but we need to find the circumference. So now we need to put that into our circumference equation. And we can just round that to 6 is fine. So we'd have 12 pi, which would give us the 37.699 inches would be our circumference in the end. For number 8, we need to find the measure of arc RS. So realize that our answer is going to be in degrees. And remember, the degrees of this arc is going to be the same of our central angle. So remember, we're going to start with the arc length, so that's our 44. The degree is the part that we do not have, so let's do a D for degree. And then out of our whole 360 times our circumference, so 2 times pi times our radius, which is this 15.28. So if we combine the numbers on the top together, so our 2 and this 15.28, we get 30.56. and then I sew the pi with it over 360, and then that's just being multiplied by that degree number is still on top, equals my 44. So just like the last one, I want to get rid of this 36, so if I multiply both sides by 36, then that gets rid of that part of the fraction. So on the left side, I will have 15,840 equals 30.56 pi, and then times my d. So again, I need to divide by this number, so 30.56 pi. Again, keep it in parentheses. All right, so when we divide that in our calculator, the degree that we will get is 164.988, and then don't forget to put your little degree measurement up there. So that's what the measure of arc RS is going to be.